Hello guys, welcome back to my YouTube channel. So today's daily LeetCode question is count the number of subarrays where maximum element appears at least k times. So we are given a nums array and a positive number k. So we need to return the count of the subarrays where maximum element is repeated at least k times, means it should be greater than or equal to k. So that is our case. So yesterday we have used sliding window algorithm. So today also we will use sliding window algorithm. So before going to the approach, so I want to discuss something that is, so this is my first approach where I explained in the yesterday's video the same approach I followed. So I got the runtime of 57 milliseconds. Then I just changed, I use a hash map here just like yesterday's problem. I will give the yesterday's video link in my description so you can go and watch that. So hash map, so that time complexity has gone to 57 milliseconds approx. So then I saw the someone else video and I just got to know that we can use a variable instead of that hash map, then it will immersively decrease it to the 4 milliseconds. So this how we can find the optimizer solutions while watching others videos and other solutions. So this is the one important point that I have learned while daily lead coding every day. So let us discuss the approach. Okay guys, this is approach 1. So using a hash map, we can store the frequency of the each element in the hash map while iterating to the array. First we have to find the maximum element on iterating the array for the first time. So we will get maximum element as 3. So our maximum element is 3. So here we can say that this can be a subarray, the first subarray. This can be the second subarray. This can be the third subarray. And this can be the fourth subarray. And the total whole can be the fifth subarray. So this is how we can return the values. So here we can store the each element frequency in the hash map, and we need to find out that if our element if our maximum element is greater than or equal to k. So then we can iterate from left pointer and right pointer and find out how many possible solutions we can make. So if our left pointer is here and right pointer is here, so we can simply justify that left minus right plus 1 will be the minimum possible number of subarrays that we can say that our maximum element will be greater than or equal to the k times, right? So this is the one solution, and let's discuss another solution without using a hash map. Okay guys, now without using hash map, so we have the first approach is the common. We have to find out the maximum element while traversing the array for one time. So our maximum element will remain as 3. Okay guys, so our maximum element is 3. Then our count should be, we will declare a variable count. So we will increment the count when we found the maximum element, and we will check if our count is greater than or equal to k, then we will take a 2-pointer approach like this. If L is here and R is here, then we can say that our count is greater than or equal to k, because we have 2 3s in the position of left and right. So we have to we can say that if R minus left plus 1 will be our number of possible subarrays with the 3 frequency. So but it's not the right way to do that, because there is a possibility where we can't determine if it has more than 3 elements. If this will be also 3, then we can't say that there will be only this number of possible subarrays. So we found another approach. We will just separate the size of the array n minus r. So this will be the possible one answer that will give us the possible number of subarrays with maximum k elements. Okay guys, now let's look into the code explanation. So as we told that we have to iterate to the array once, and we will just find out the maximum element. So we will first initialize maximum element to the 0, and we will iterate to the array once, and we will find the maximum value. So again we will take variable count, right, left, and result. So we are using sliding window algorithm, so we have to use 2 pointers. So left will be 0, right will be 0, count will be 0, and result will be 0. So we will iterate until the right is less than length of the array. So if nums of right equal to maximum element, is right equal to maximum element, is 1 equal to 3, so our maximum element will be 3, so I wrote 3. So is 1 equal to 3? No. So we will simply increment the right pointer. So is 3 equal to 3? Yes. So we will increment count by 1. Then next we will increment right pointer also. So is 2 equal to 3? No. Is 3 equal to 3? Yes. So our count will be 2. So here is a inner loop. If count is greater than or equal to k, is 2 greater than or equal to 2, the condition is true. So we will add the result to nums of length minus right. So our right is at the third index, so our length is 5. 5 minus 3 will be 2, so our result will be 2. So we will, if our left pointer element maximum is equal to maximum element, then we will decrement the count. So it is 1 is equal to 3. No. So we will simply increment left pointer, and we will again add 2 to the 2, because our count is greater than or equal to k. So we have to add the 2 to the result, so it will become 4. Okay guys, now our left element is equal to maximum element, so our count will be decremented by 1. So our count will be 1. So the next we will increment the r to the last element, and we will check if our count is greater than or equal to 2. So here we encountered another maximum element, so our count will be 2. So which means that our loop will run once again. So we have to iterate one more value. So we will again 5 minus 4 equal to 1. So 1 will be added to the result. So our result will become 5. So is this element is left equal to maximum element? No. So our loop will iterate once again. So left pointer will be incremented, and we will again add a 1 to the result. So 5 minus 4 will be 1, so we will again add 1 to the result, so it will be simply 6. So then we will check if our left pointer element is equal to maximum element. Yes, our left pointer element is equal to maximum element, so count will be decremented by 1, and inner loop will be terminated, and right will be incremented, so our outer loop also terminated. So we will simply return the result. So this is the I hope you understand the video and the approach. The code is in the GitHub. Thank you.